pins the processor has, so that you can select the right motherboard to put the processor onto. The older standard is called LGA 775, which means that the processor has 775 pins to connect to the motherboard. The new processors has a lot more because they're now bypassing the NOR gate completely to talk to memory. So that's why they have more pins, because now they need to address and deal with more peripherals directly from the processor. The 1366 LGA 1366 or 1366 is for the i7 processor. So when you select an i7 processor, or at least certain i7 processors will require more pin counts compared to the i5 processors. Okay. Any questions at this point? Okay, so we want to write down here. Okay, so let's see, go back to, okay, pay attention to processor manufacturer. Usually it's either Intel or AMD. You also have to pay attention to the pin counts, or they call it form. What is the technical name of that? Socket type. Because if you buy an Intel processor and you specify an AMD motherboard, they won't work. I mean, you can't even plug it in physically. So you got to make sure that you select the right socket type and select a motherboard of the same socket type. So we're going to go select 1156, and it will just narrow down the choices to all the processors of that socket type. So here we have the i5-750, i5-661, and we want to select the one that is comparable to the other one. So we'll go ahead and 665, 540. These are i3s already. Let's see. We can select by Core i family. Now, when you see these names like Linfield or Clarkdale and so on and so forth, they describe a particular process to make the processor. So, depending on the family, it can have a different type of technology. Like the Linfield technology uses a 45 nanometer process, where the Clarkdale uses a 32 nanometer process. What is a nanometer? A nanometer is basically 1 nanometer is 1/1 billion meter. Yeah, so that's really tiny. What happens when you have a process or technology using a smaller, what happens when this number is smaller? Is it good or is it bad? First question. It's a good thing. Now, how is it a good thing?
Less space.
It uses up less space on the silicon die itself, yes. But to the consumer, what is so good about using a 32 nanometer technology processor as opposed to a 45 nanometer processor? Smaller. Power consumption. Okay, the first thing is power consumption. If you look at the power consumption, you can see that, hey, it doesn't add up. Oh, okay. There are two things affecting power consumption, because if you look at the power consumption, it seems to contradict what I just said. The first one is a quad-core processor with 4 different processor cores. The second one is a dual-core processor. So the quad-core processor, in this case, is only going to consume 82 watts instead of these 87 watts of a dual-core processor. But we're forgetting one thing, because the clock speed also dictates, also helps to dictate the amount of power consumed by the processor. This is a 2.4 gigahertz processor. This one is a 3.33 gigahertz processor. So that's why the power consumption is almost the same, even though one is a quad-core processor and the other one is only a dual-core processor. Okay, but typically speaking, we want to go for a smaller process. In terms of manufacturing technology, we want to specify a smaller nanometer process instead of a bigger one, because a bigger one usually will end up consuming more power in the end. So we'll go ahead and type this here. Okay, the process or nanometer determines the size of a transistor on the processor. Typically, the smaller, the better. More power efficient. And also faster. In general, it is faster too. Any questions at this point? What other things should I be looking at when I compare processors? Both of these are Core i's. Okay, this is Core i5, Core i5. This one has got 8 megabytes of cache. This one has got 4 megabytes of cache. So which one is better?
The 8.
The 8 is better. Okay, very good. In the end, which one is faster? Since they use about the same amount of power when they're at the max, which one do you think is going to be the faster processor? That's a trick question, by the way.
661 because of
the increased clock speed. Now, yes, in theory, the second one is going to be faster for two reasons. Okay, if I just look at the power consumption, the one is 82 watts and the other is 87 watts. Everything else being the same, the one that is consuming more power is usually the more powerful processor. It can process information faster. But this is not, everything is not the same because this one is a quad-core processor and this one is a dual-core processor. So how can a dual-core processor be consuming more power than a quad-core? It has to do with the clock speed. Okay? If you can keep the processor busy, then the second choice is actually faster, even though it does not have as many cores on the die as the first one. But the question now is, can you keep the processor busy all the time? Well, it depends on many factors now. What type of software are you running? Okay, are you using it for gaming or are you using it for word processing? If you're using it for word processing, I would say that these two choices would not, you cannot differentiate the speed between these two choices. If you're playing games, then the quad-core processor may be advantageous, at least on paper. But in reality, is it really going to be faster? It's hard to say. Okay, it's really hard to say because it depends on whether you can keep all four processors all busy at the same time. Okay, because if you can only keep 2 of the 4 processors busy at the same time, you might as well just go for a dual-core processor because the other cores are just sitting there doing nothing anyway. Okay, so I think within these two choices, it's a little bit hard to find out which one is faster without knowing what you're going to do with it. Yep.
That's just what I was going to ask. I mean, doesn't it just boil down to what program you're running, basically? It's like, I mean, otherwise, I'm thinking for myself. I do a lot of audio, so it's like it's better for me to have more cores because a lot of the programs you can, you do this task, you do this task, and separate and delegate like what you want to do versus I just can't do that on a dual core. And dual cores actually trip out a lot of ones because it needs to run on a single core anyways, and so it's trying. The fight is what I've read a lot as the end of the line, like tech support kind of like is that like Pro Tools, for instance, will fight itself on the dual core. I had that like with a laptop, a lot of problems with needing to like that it doesn't help anything. But then going up to a quad core, I have enough where it's not. I can actually delegate to some degree where I can't in a dual core.
Now, but in both cases, you have to look at one of the parameters here. It does not say on this sheet, but it depends on the memory speed. Okay, a lot depends on the memory speed because remember, memory is really slow compared to the processor, so it depends on how fast you can feed the processor. Now, how fast you can feed the processor to keep the processor busy all the time also depends on the program itself. Some programs are written in a way where you can truly utilize the full potential of the processor. In other words, the program tends to execute code within a very small region of the program almost all the time. So you can keep almost the entire program or 80% of the program in cache most of the time. So your program can execute really fast. On the other hand, poorly written programs will access memory all over the place. They will use subroutines and code all over the place. Then your cache is useless in that case. If you cannot execute the program mostly out of the cache and you have to go fetch memory from the memory bus, then it doesn't matter which processor you pick, because even if you have 4 cores inside, you cannot keep them busy just because you cannot feed instructions to the process exactly. So a lot depends on the type of software that you're running, as well as how fast your memory bus is. Okay. But what we're trying to do is to find out, the same 650 processor core. Okay, so we have a 650 here, and you can also see, the rating of these processors. This one has got 39, rating, and it's almost all good. So, it's either because the price point is really good or the performance is really good. Usually it's one or the other or both. So we'll go ahead and take a look at this item here. It's 170 or 180 bucks, which is not too bad. We'll go ahead and add it to the cart because we want to find out in the end, how much are we going to spend. Okay, so once we add it to the cart, we want to look at the processor and look at the other parts or the specifications of the processor. This one has a maximum power consumption of 73 watts. Now, it means that when you specify a power supply unit, the PSU, you have to factor in at least 73 watts to the processor itself. It does not mean that the processor will consume 75 watts all the time. Most of the time, I would say that it is going to consume maybe 15 to 20 watts at the most when you're doing nothing and you're just idling. Modern processors are very, very good at saving power when you have nothing else to do. So that means, even though it says that it is a 73 watt processor, most of the time it is not even coming close to consuming that much power. And then when you look at the details of the processor, you can see all the technical specs here. It is always important to look at the technical specs, when you try to put something together, just to make sure everything works with the other components. So in this case, we have the LGA 1156. We know that already because that's how we selected the processor. The process is a Clockdale process, which is not the latest and greatest, but nonetheless, it is not a bad core. It's not a bad process. It only has 4 megabytes of cache. Okay, but it is, of that price range, it is not bad. Oh, I take my words back. It's using the 32 nanometer process, which is good. Okay, that's a good thing. Has 64-bit support, which means most modern processors do. So that usually is not a big concern. It has got hyper-threading support. Hyper-threading is kind of like multi-core, except it is not using a separate core. But it does speed up programs that are running at the same time. In other words, if you have a dual-core processor that supports hyper-threading, it's almost like having 4 cores. Okay, in terms of the efficiency of running 4 things at the same time. Okay, not exactly, but it's a good technology to have. It has got integrated graphics, which may or may not be something that is important. Unfortunately, all Core I processors have including graphics support. In other words, you're buying it, you can disable it. Okay, you can say, I have my super duper NVIDIA card, I don't need the built-in support of graphics on the processor itself. You can turn it off, but it is already included. It's on the die, it's on silicon. There's no way you can say, I don't even want it on the silicon. Okay. Graphics base frequency, once again, that is irrelevant because we're putting together a gaming system with its own dedicated graphics card, so this part is not important. Virtualization technology support, it depends on what you're doing. For me, it is important because I run virtual machines. I run Linux as my host operating system, and then I can run a virtual machine, then I can run Windows, FreeBSD, and